Here are the main equivalents. Okay. This one, this equation is in the same form as this equation. This is like an x equals log base 2 of y, right? So this is like well, that's if x equals 4 and y is t squared plus 3t plus 5. Okay? So equivalent form is y equals 2 to the x, right? So if x is 4 and y is this expression, then can you write out y equals 2 to the x? That would go here. Except you're not going to use y and you're not going to use x. Right. This is going to be your y, this is going to be your x. Write that expression, but plug in what the y and x are. Okay, well, everybody seems to be writing something. So, and some of you are copying down what I wrote here. I ask you to do something with it, right? So you want to do that. Y'all getting pretty good at that, okay? And sometimes it just helps to write that down. But don't write it down because you think you got to have it in your notes. If you do, you can write it down later. Wait for the video. Okay, so, well, y equals 2 to the x, and y is this. So you're going to get t squared plus 3t plus 5 equals 2 raised to the x, which is just 4. Okay? So it's very easy to solve that equation. Now the other thing you could do, the alternative way to get the same equation, is to say, okay, I'm going to do this. I'm going to do 2 raised to the log base 2 of t squared plus 3t plus 5 equals 4. And using the property that 2 to the log base 2 of whatever equals to whatever. In other words, the 2 to the x function undoes the log function, right? So this function undoes this function, and we get t squared plus 3t plus 5 equals, and it's not 4, it's, you do 2 to this side equals 2 raised to this side, right? Do 2 raised to this side, so don't make that mistake like I did. 2 to the 4th. Of course, what's 2 to the 4th? Yeah, 16. Okay? Now you do that. That's it. Okay? 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So anyhow, so now you've got, and of course you can do the same thing on this, with this equation, because it's exactly the same. So whichever way you do it, by switching the x's and the y's and the function, or by applying the inverse function to both sides, you get a very simple quadratic equation that you can easily solve. Okay? And everybody's okay with solving quadratic equations as far as I can remember. Okay? Doesn't mean you don't occasionally make mistakes. Everybody does. Try not to do it though. Okay? So there you have it. Now, I'm going to put this in slightly different terms, because using x and y relates directly to what we did with the tables. But it gets a little confusing because sometimes your equations will have x's and y's in them that have different meanings. Okay? So I'm going to state the same properties in a way that you might want to remember them, but remember them, if possible, by understanding how they relate to reversing the columns of the table. That's a fundamental way you understand an inverse function. So, I'm going to say that, let's see what notation I want to use here. 2 to the a equals c, and I'm using a and c instead of a and b because b is going to have a function that we see a little later, is equivalent to a equals log base 2 of c. Right. So if I write the equation, well, the other thing is, if that's one thing you got to know about logs. You're going to need to know it for the test, but it's going to be easy because once you practice this, I find that classes get it very easily. Okay? Seems a little strange when you first do it. A little practice. It goes smoothly. So you got this. That's all you need to solve logarithmic equations and exponential equations, assuming they can be solved. Okay? So, take the equation. This equation. Okay, is that in one of these forms? Well, now it's got to be in the form that has a log base 2. Is it in the form of this equation? Sure is. So what do? You identify A equals x minus 3 over x plus 5. C equals 3. So 2 to the a equals c. Says that did I even write that correctly? Yeah, I did. I'm wrong here, because what I should be getting is 2 to the third equals x minus 3 over x plus 5. And yeah, I got my A and my C backwards. I can't do clerical stuff. C is what's inside the log, right? So I wrote down C equals 3. which is just plain old ignorant. Okay? Let's be careful. And A, well, C is what's inside here, the x minus 2 over x plus 5, and A is the number I have over here. Okay? So you got to be careful about that like I was. I know what the form is, so I don't ever look back at this, but it's no excuse. Okay, so you have this. That's a simple equation. How do you solve it? Well, you write that as x minus 3 over x plus 5 equals 8. You multiply both sides by the denominator. And you end up with x minus 3 equals 8x plus 40. Subtract 8x from both sides, add 3 to both sides, and divide by 7. Okay? In other words, it's a simple linear equation. I'm not going to... I assume you can automatically you can automatically solve that equation. Okay? Just kind of reminding you of the steps, but once you're this, you know what to do. Okay? Okay, then another alternative way to solve it is to use either this or this. So what we do is, okay, we take the same equation, and we want to get to that. Well, we want to undo the log because our variable's in the log, right? Our variable's all bound up in here, so we have to use one of these rules. Well, it's going to be this rule because the thing inside the log base 2 is the thing we want to get out of the log base 2, and this rule gets it out by saying that 2 raised to the log base 2 of x minus 3 over x plus 5 equals 2 raised to the third power. And then using this property, the inverse property, 2 to the x function being the inverse of the log base 2 function, we find that we have x minus 3 over x plus 5 equals 2 to the third, which is 8, which is the same equation we've got here, and we solve it the same way. Okay? It's pretty much a matter of taste whether you do it like this or like this. This is just kind of like taking the square root of both sides when you have x squared equals something, right? Because the square root is an inverse function to x squared, provided x is positive. Okay? And this doesn't look the same, but it's the same idea. You do the same thing to both sides. In the case of the square root of x squared, you kind of get the x out of the square root. Here you're getting this whole thing out of the log. Okay? Okay, so I'm going to ask you to practice that some for homework. There are your rules. I'll write them down for you. You'll see them in your homework, assuming you can see your homework. Okay? And that's as complicated as this is going to get. I'll give you more complicated equations. We'll do that after the midterm. I mean, yeah, one complication is, what if it was 5 times the log base 2 of this equals 3? What would you do? Well, you got a 5 there. It's not in this form anymore. But if you divide both sides by 5, it is. That's not hard. Okay? And yeah, it doesn't get too much harder than that. And you can do some pretty powerful stuff.